Right, so I'm Marc Saunders. I run Renishaw's global network of additive manufacturing solution centres, including the one here in the UK that's been working with the partners here to engineer and produce the bike. And what I'm going to do is take you through the processes we use in the manufacture of the lug set that we then deliver back to Robot Bike Company for them to assemble into the finished bike for the customer. Just firstly, a few words about Renishaw. I'd like to reiterate Chris's welcome to you all at the start here. Renishaw is a UK headquartered, but very much a global company. You're at our global headquarters here. We employ a little over 4,000 people globally in over 30 countries. Turnover last year was a little under 500 million, market capitalisation about £2 billion at the moment. So we're a substantial business and we have interests in a very wide range of engineering fields. So the core of our business is industrial metrology. So that means measuring parts and providing feedback into manufacturing processes to produce precision components. So the phone in your pocket, the car you drove in here today, the aeroplane that you take on holiday, all of those will have been touched by Renishaw technology in their manufacture to make them efficient, to make them high performance, and to make them cost effective. So we're deeply involved in the advanced manufacturing field on a global basis. But also some other things you may not know, and if you take a look around the demo area outside later, you can see some of these things. We're also involved in a research field, so we make spectrometry systems that are used in various forms of research, biomedical research, materials, pharmacology, etc., as well as medical devices. And of course there's additive. Additive we use in industrial fields, consumer products, but also in the medical arena. So we have a neurosurgical business. We also make implants to help people that are injured, which I think could be quite useful in the context of this product if you're not quite as talented as the rider that we saw on the screen earlier. So yeah, if you do come a cropper, we have the means to put you back together again and get you riding again. Okay, so this is a bit of repetition to what some of the stuff Mike said. What is it about 3D printing or additive manufacturing that makes it so relevant to a product like this? Well, it's its adaptability. It's the fact that we can support innovation in product design, integration of numerous functionality into single complex components. We can make things with internal details, things like some of the double lap joints and the internal cable wiring. All of that can be integrated neatly into designs in this instance. We can make things lightweight, minimizing the weight and support the optimization that Altair talked about earlier. We can really make that a reality with the flexibility of additive. Another key point is that we use materials very efficiently. There's almost no waste in the process. So you'll see in a moment the powder that isn't soldered, isn't welded together, can then be reused. And of course it supports customization all around short lead times. So it allows for innovation in business models as well. And that's, I think, one of the really interesting things about Robot Bike Co. is it's not just a really interesting high-tech product, but it's also a very different way of taking that product to market. And I think that's a key characteristic of the disruption that AM can introduce. So let's look at some of the processes that we use. There's a process chain essentially here, which takes us from the CAD model that Hyeta is producing as a result of the calculations that they do around your measurements and riding style, and then all the way through to a finished lug set that's then ready for assembly into a finished bike. And so the process that we take is we prepare the build, and we do that in a software tool. We then produce the components. So we slice that build into, in this case, over 2,500 60-micron thick layers that then are built up to make the lug set. We then heat treat that, finish machine it, and then finally obviously check that it is conforming to the specifications that the parts have to meet. So let's look at some of this. The first step is the build preparation. So you're looking here at some software that Renishaw makes called QuantAM, and what we're doing in here is assembling the bike frame set, the lug set, together on a build plate. So we've got one part missing. It's the yoke that Paul looked at earlier with the optimization process, and we're going to add that into the build environment. So here we've got it on the screen, and we're just checking that it's in an orientation that we're comfortable with. Once we've done that, we'll start to then insert it into the build frame, so it takes up its place in there. And then the next step, there it is, so it's now in its location. And the next step will now be to look at the supports that we're going to need. Overhanging features in additive manufacturing do require some support, both for physical support and also to soak away heat. Otherwise you can get distortion and surface finish issues with the part. So we have to add those supports in. That's done automatically, but we also have the option where we know from experience perhaps they're not needed to remove supports so that we get an optimized build assembly that we're comfortable with. Okay, so now we're good to go. So we get on with the process. So we're now on the machine preparing the build environment. So these titanium lugs are actually processed under an argon atmosphere. As I mentioned, they're sliced into layers, some 2,500 layers, and this is, you're seeing one of the layers being processed here. You can see there's multiple components there, all being welded together by the laser beam in location. We then wipe another layer of powder over the top of that, and then we go again, and we build up the part layer by layer by layer, creating these intricate shapes. What you just saw was the powder being removed. All of that unsoldered powder at the moment, unwelded powder, sorry, is available for reuse. So this is still under an inert atmosphere here. It's not being oxidized, so we're not wasting any powder. And eventually we end up with our build plate clean and ready to be removed from the machine. A little bit of final sweeping up to make sure that there's no powder before it goes into the heat treatment furnace. And once we've done that, we're going to be ready for machining. So here we have post-heat treatment, a finished build on the plate, and you can see all of the supports there in place. Those have to be removed before we move on to the machining and inspection process steps. Okay. If we now look at machining, here we've got the parts now have been removed from their support. One of the first things we do in any machining process to control it is to set it up accurately using Renishaw probing, which is what we're doing here. So we're finding the location of that bore that we're about to then machine to produce a finished, precise bearing surface. Now we get on to the machining process itself. Lots of coolant. This is titanium after all. Not the easiest material to machine, but we get on with that and we produce the precision finished surfaces. We then check all of that using a coordinate measuring machine. So in this instance, it's a 5-axis CMM inspection system called Revo that we're using to measure this part. And we're spiral scanning that bore to check not just its size and position, but also whether it's tapered, whether it's sufficiently round to meet the tolerances that are set by the product design. Okay, so once we've done all of that, we've got a lug set that's ready to go back to Robot Bike Co for assembly. Just a few words about the Solution Center. This project really has been a great example of what we're doing in our network of solution centers, where we're working with customers in a very, very broad range of fields, from consumer products to aerospace to automotive. And what we're doing with them is working collaboratively on developing their product and the process together. As you can see, there's a close interaction between the design work that we can do and the capability of the process. So those two things have to work hand in hand, and that's really the relationship that we've had in this instance with Hyeta, Altair, and Robot Bike Company to optimize this design. We have this network of centers now where we're working with companies around the world on a range of applications, and the idea really is to industrialize the additive manufacturing process and get it ready for deployment in products that you can either buy or use every day.